welcome to today's video. Today we are going to discuss study of compounds third chapter, that is HNO3, nitric acid, a very small chapter, so it will not take much of your time. So let's begin the video. HNO3, what do you understand? It's nitric acid, right? By the name itself you can understand that it's nitric acid. Now the first question coming into your mind, how does nitric acid look like? Fine. Nitric acid structure is N is in the center, central atom is N, you can understand, least electronegativities of N. Okay, central atom N, one double bond over here, one coordinate bond over here, clear? One double bond here, one coordinate bond here, one O over here, O bonded with H. In organic chemistry also, you will have this part in organic chemistry, not now, 11. Clear? In 11 also, you will have this part. Inorganic compound, a structure with this part. Not there, right? I'm not saying also, okay? Okay. Electron dot structure, if it is asked, then what will you do? Here you see nitrogen has got 1, 2, 3, 4, 5, 6 electron. So here oxygen is sharing how many electron? 1 electron. So oxygen sharing 1 electron. Fine, fit and fine. Okay. Acha. So oxygen dot hollow. Clear? Acha. Here also oxygen is sharing how many? 4 electrons. 1, 2. 1, 2, 3, 4, 5, 6. Clear? So here oxygen is sharing 2 electrons. Nitrogen also sharing 2 electrons. So let's remove 2 electrons from here. Let's remove this bond. Let's write. Clear? So this sharing is done. First sharing done. Okay. Properly let's write. Suppose here is oxygen. So oxygen is sharing 2 electrons, nitrogen also sharing 2 electrons. Oxygen has more 4 electrons. Fine. Okay. Here oxygen is done. So how many electrons left with oxygen? 1, 2, 3, 4, 5. So 6 electrons left. 6 electrons here. So 1, 2, 3, 4, 5, 7. 1, 2, 3, 4, 5, 6, 7. 7 electrons done. Another electron, this electron, it will share with nitrogen. Clear? So let us remove this electron, let's keep it over here. Clear? Shared? Now see, oxygen has now completed its octet. Nitrogen 1 has lone pair, no? This lone pair will go to this oxygen, okay? 1, 2, 3, 4, 5, 6. So this lone pair will now be shared with this oxygen. Clear? Oxygen located very far away, so let's try to write it over here. 1, 2, 3, 4, 5, 6. So this now will go with this. Clear? It's not sharing actually. Not that kind of sharing you are thinking. It will go like this. So we write like clear that this is the structure of nitric acid. Understood? This is the structure of nitric acid. Electron dot structure. Bond line structure I have done before on, which is electron dot structure. Okay, next. Directly going into the main thing, laboratory preparation. Laboratory preparation. How do we prepare nitric acid? We prepare nitric acid by using either NaNO3 or KNO3. Same reaction, you know. So NaNO3 we add it with sulfuric acid. Your favorite. Next chapter is sulfuric acid, king of chemicals. Concentrated. This has to be concentrated. If it is concentrated, what will happen? NaHSO4, correct? Temperature below 200 degrees Celsius. So formation is NaHSO4 plus HNO3, correct? NaHSO3 plus HNO3, correct? So reaction gives you HNO3. So this is the laboratory preparation reaction for. Now if you place over here KNO3, here it will be KHSO4 plus HNO3, clear? So this is how do you get HNO3 from laboratory preparation. Understood? First reaction is laboratory preparation. Next. HNO3, does it have any color? No. It's supposed to not have any color. Why does it have a color? Whenever you prepare in laboratory, you will find yellow color. Why? How? Why and how does it get the yellow color from? So it happens is basically your HNO3, it decomposes to form H2O plus NO2 plus O2. Clear? This color reddish brown. It dissolves in water to form kind of yellowish. Clear? So color is due to NO2. Clear? Understood? Color is due to. Now how to remove the NO2? I mean how to remove that color, yellow color. How do you do that? Two options you have. First is put up CO2, it will absorb NO2, colorless. Another option you have is more water. What will happen if you add water? Correct? You add water to this. What will happen? This will react. I am talking about this. HNO3, no reaction will happen. But this will react with this to form this. Again, this is unstable. This will get oxidized to form this. So as a result, you are getting HNO3 only. Clear? Understood? So this is one way, or you bubble CO2. That will absorb it. Clear? Two options you are having. Clear? It will dry off the warm acid, which makes it colorless. Clear? Or you do this. Two options you have. Either of this you have to do. Either of this you have to do. Clear? Next, coming to the industrial preparation. This was laboratory preparation. Now we are coming to how the industries prepare this. How does the industry prepare this? Industry prepares it through a process called Ostwald's process. What process? Ostwald's process. Ostwald's process. Ostwald's process requires 3 steps. 3 steps done. First step says oxidation. What type? Catalytic. Catalytic oxidation of ammonia. Now tell me, I am not writing the reaction. Clear? You already know catalytic oxidation of ammonia. Ammonia chapter we have done. Watch the previous video. You understand what is written. Nitrogen monoxide is formed. Correct? Nitrogen monoxide is formed. Very good. Okay. Next, you will find that this reaction is ectothermic. That I have also told you. Next, second point. Second step. This NO is unstable. That also I have told in the last video. So that will form NO2. Clear? Second step done. Oxidation again. Oxidation of nitrogen monoxide to form nitrogen dioxide. Correct? Third step in Ostwald process is that whenever you pass this NO2 in water, or absorption of NO2 in water, clear? Absorption of this NO2 in water results in the formation of HNO3. That is the third step and the final step where you get HNO3 as your product. This is the Ostwald process. NO2 plus O2 plus H2O forms HNO3. Clear? This is the reaction that you need to get. Understood? Clear? One thing you have to remember, that HNO3 is also a volatile acid. Volatile acid, HNO3. HCl, volatile. H2SO4, non-volatile. Okay? H2SO4, non-volatile. Next chapter is H2SO4. Clear? This was all about Ostwald process. You need to remember. Following Ostwald process, we need to read the last part of this chapter. That is chemical reactions. Ready to read the chemical reactions? Let's do it. Chemical reactions. Chemical reactions. Let's see what chemical reactions can we have. Okay. First is, whenever you react a base with acid, it has to form a salt water. That I am not saying anymore. That's very stupid to say, right? Okay, next. If you react with bicarbonate, it will give you H2CO3 plus CaNO3 whole 2. H2CO3 cannot stay as H2CO3. So it will be forming H2O plus CO2. Clear with that? That hopefully does not have any problem. Okay. Next comes metallic sulfite. That is also again H2SO3. H2SO3 cannot stay as H2SO3, right? So it will dissociate into H2O plus SO2. No samasya. Okay. Next, oxidizing property. Very powerful oxidizing element. This is a very powerful oxidizing element. That is why in most of the cases you will not get H2 as the product. H2, if you want even as the product, you will not get it. Why? Because it oxidizes. Clear? Suppose I write what do I write? Let's take carbon plus HNO3. Clear? What will happen? This will oxidize, so CO2. Rest products remain same, that is H2O plus. Remember this part will change with reaction, clear? But this part remains the same. H2O plus NO2 remains same. Acha. NO2 is only if this is a concentrated solution. If it is dilute, then this NO will become NO. Simple. H2O plus NO only in case of dilute, NO2 only in case of concentrated. Clear? So in this case, will it be NO2 or NO? Concentrated written, so NO2. Clear? So whenever it is concentrated, it has to be NO2. Whenever it is diluted, it has to be NO. Clear? Next comes action on metals. Suppose I write Cu plus HNO3. What will be formed? CuHNO3. That is not a formula. So CuHNO3 whole twice, fit and fine. What is the other product? H2O, right? Plus NO2. As usual. Clear? This is concentrated. Clear? Understood? This is, you need to remember. Now, had I given this as dilute, suppose let us write this as dilute, what will happen? What changes will take place? Fine. Any other changes? No. Only change is NO2 will become NO, nothing else. No change in otherwhere. Nowhere any change. Only this will change. Clear? Last reaction we will be doing is exceptional reaction. Exceptional reaction is, you see, metals reacting with HNO3 does not need hydrogen because it is an oxidizing. Fine, fit and fine. If I write Mg plus HNO3, dilute 1%, very dilute, it results in the formation of Mg3NO2 plus H2O plus NO2. Basic trait. Suppose this was to happen, but this does not happen. What happens? Fine, H2 gas releases. That is 1% dilute. Very dilute solution. Then it reacts to give H2. Another element is Mn, that is manganese. Reaction remains same. Instead of this, write Mn. Clear? Understood? So both of these elements will release hydrogen from nitric acid. Dilute 1% nitric acid. Clear? Concentrated you give, same reaction you will get. H2O plus NO2. Clear? So that was all that you need to read from nitric acid. Very small chapter from the syllabus definitely. In the next video, we will be discussing about the last part of study of compound, that is sulfuric acid. So see you all in the next video.